I'm really excited that we get to talk about async Python today. This is going to be so much fun. Here's the part where I tell you I am definitely going to post the slides on my site tonight. I've been in talks like that where I've been chasing the speaker and do they post them tonight? Do they post them tomorrow? Never? Yeah. So I've already posted the slides on my site tonight. I'll set them here in Slack as well. But let's head to robrich.org, robrich.org. We'll click on presentations here at the top. And here is async Python good it is. The slides that we're going to look at today are online already, as well as the code up on our GitHub repository. So you can head to robrich.org, open up those two, and you'll be able to get at the slides. They're online right now. Achievements unlocked. Woo! While we're here on robrich.org, let's click on About Me and see some of the things that I've done recently. I'm a Shoreline developer advocate. I'm also a Docker captain. Microsoft has given me some awards as well. And I'm a friend of Redgate. AZ Give Camp is really fun. AZ Give Camp brings volunteer developers together with charities to build free software. We start building software Friday after work. Sunday afternoon, we deliver that completed software to charities. Sleep is optional, caffeine provided. If you're in Phoenix, come join us for the next AZ Give Camp. Or if you'd like a Give Camp closer to where you are, hit me up on email or Twitter or Mastodon, find me here at the event, and let's get a Give Camp in your neighborhood too. I worked on some other things. Here's some books that I've been working on. I run some user groups, one in Utah and one in Phoenix. And one of the things I'm particularly proud of is I replied to a .NET Rocks podcast episode. They read my comment on the air and they sent me a mug. So there's my claim to fame, my coveted .NET Rocks mug. Haha. So let's dig into async Python. Now, taking a step back before we dig into Python's implementation, why do we want to async? What is asynchronous? I found this definition related to or being a computer operation that it can occur independently without waiting for another event. Or taking a step back, it's doing two things at the same time that are not dependent on each other. So that's kind of cool. If we can do two things at the same time, then maybe those processes don't need to wait. Imagine two employees working independently versus one employee that has to do both things. So asynchronous, we're doing both things at the same time. Synchronous, we're doing one thing after another. Now, why would we choose asynchronous stuff? Well, it depends. If we're working client side or server side, we'll do asynchrony for different reasons. On the left here, client side, we have two windows in our application. Now, they are asynchronous. They can run in parallel. They're independent. I can switch between various documents within my application. So we have asynchronous stuff so that those two documents can behave independently. We have higher interactivity client side. By comparison, server side, we use asynchrony to be able to leverage our hardware better. Here on the right, in the left diagram, we just carved up our server into equal pieces. And because we carved it into equal pieces, if you use your piece, that's great. If you don't use your piece, then it's wasted. If you want to use more than your piece, well, you're out of luck. You can't do that. By comparison, here on the right, we've chosen a more asynchronous method where we say, you can use as much as you need, and when you're done, let it go, and we'll give it to others. Server side, we use asynchrony to be able to yield the threads so that other requests can come in and do it. Client side, we use asynchrony to allow more things to happen for the users, higher interactivity. On the server side, it doesn't take less time. It's that we're using our hardware more efficiently. On the client side, it also is not that it takes less time. It's that we're more available and more interactive for user. So as you grab these slides from robrich.org, you can click on each of these blue links to see interesting things about the pieces that we're digging at. So why might we not want to do asynchrony? Why might we want to do synchronous things instead? Well, it's easy. We can take a look at our methods. We can start at the top and we can just work our way down through the code. And it's really easy to understand what's going on. The moment that we have asynchrony, we have a lot of wacky things going on. For example, race conditions. Let's double click on race conditions and understand that a little bit better. Here's a fun meme about a race condition. Imagine these two employees that are completely disconnected, these two programs perhaps. On the left, we run this line. If the file exists, then on the right, we run this line. File exists equals true. We've already determined that the file doesn't exist yet. So we go now here and say, nope, it doesn't exist. We got the wrong answer because by the time we ran this line, the file did exist. Let's flip this condition and say, okay, so the file does exist. So let's say if the file exists, then we delete the file. Then we try to load the file that now doesn't exist, and we fail. That's a race condition. Why might we avoid asynchrony? Because we avoid the whole class of race conditions. Now, race conditions come from shared mutable state, so there are other techniques that we can use to avoid shared mutable state. Maybe we don't mutate state. Maybe we copy the data instead of mutating the data, and that might help us avoid race conditions. Or maybe we just don't asynchronous, and that can help us avoid race conditions. Pardon me. Okay, so here inside Python, what are our strategies for working with asynchrony? Well, here's two that have been famous for quite some time. We have subprocess.popen, and we have threading.thread. Let's double click into each one and take a look at how those might help us do asynchronous things inside of Python. First, popen. Now, the cool part about popen is we can run anything. We can start an executable. We can start a process written in another language. We can start a Linux shell command. We can run anything. The downside is that we don't have a whole lot of visibility into that thing that's running. We might be able to get the standard out and standard error from that program. We might be able to get the exit code from that program, but we can't really pass in variables very easily, short of just command line parameters at the beginning. We can't exactly harvest the results very easily, short of just parsing the streams on the way out. We don't have a whole lot of ways to be able to share variables between these things. These two processes are now completely isolated. By comparison, if we look at threads, threads allow us to be able to share variables between them. We can just create a variable, launch a thread, and read that variable. Excellent. On the downside, spinning up threads is really awkward. Now we have race conditions because we're sharing these variables between the threads. It's really awkward. And one of the things that's particularly interesting is if we're in a desktop application, there's usually only one thread managing the desktop user experience. So we need to marshal back to the UI thread to be able to do any screen updates. Are we on the right thread? Are we not on the right thread? How do we get to the right thread? That's a whole nother level of awkward mechanisms within our process. Now, if we're running with a web server, we're less concerned with the UI thread because we're just rendering a response stream. But it's still a big spot for shared mutable state and therefore race conditions. We're using variables across threads, and if different threads update variables in different ways, we could yield ourselves a really unexpected result. So we looked at popen, we looked at threads, and neither of them are really great solutions for asynchrony inside Python. Yeah, so should we just abandon this whole asynchrony thing and just not? We definitely could do that, but there is a third mechanism now that's relatively new in the Python community, which is really cool, the asyncio library. Now, the cool thing about the asyncio library is it is now built into Python. So you can leverage it without having to pip install anything or poetry add anything. You can just use the asyncio library. It's excellent. So asyncio, the cool thing about asyncio is that you can think synchronously and code asynchronously. We can just look at our methods from the top to the bottom and we can understand what's going on. But from time to time, we'll yield the thread back to the process so that other threads can process this work, other tasks. Pardon me. So asyncio, it has the async and await keywords. Now, the really cool thing is async and await in Python works pretty much the same as async and await in other languages. Async and await was built in C# and implemented in JavaScript as well. And you're probably seeing it in all kinds of languages. It's a really elegant paradigm for dealing with asynchrony in this way. As we code it, it builds up it looks very synchronous, but behind the scenes, it builds up a state machine. And that state machine is resumable so that when it enters the next time, it knows what step it's on, and it can continue on with what it's doing. Now, that state machine happens completely behind the scenes. We don't need to worry about it at all. But if you wanted to peel the onion, that's how it works. Think about a big switch statement inside of a method where it keeps track of which switch element it's on. So asyncio. We start by importing the asyncio library, and then we can await content, and we can define our methods as an async method so that others can await this method too. That's that methodology of how we build these asyncio asynchronous functions. So asyncio, it's a lot easier to deal with. We can think synchronously while we code asynchronously. We can share variables. We have great visibility into all the other tasks running alongside of ours. And it's a great way to be able to build up this asynchrony. But it is not threads. These are all running on the same process. So it's just really good at context switching. If we have a CPU-bound process, we do need to spin up threads to be able to run them in parallel. But if we don't need threads, if we have an IO-bound process, and we just need to yield the thread so that other processes can catch up, then async IO is perfect. So async IO, it's great for IO-bound workloads. It's not perfect for CPU-bound workloads, but it's a really clear and elegant methodology for being able to do this type of work. So let's dig into how we might build up an async IO program. So I'm going to start by installing the library. And the cool part is I don't need to install anything because it's been built in since Python 3.4. 3.8 is the currently the last supported language version. And you're probably running 3.10 or 3.11 now. So yep, async IO is just built in. It's perfect. So let's build up an async IO program. We'll start by saying import async IO, and then we'll create an async function. Async def myfunc, or I'll just call this main. Print hello, and then we'll await async io.sleep. We'll just sleep for 1 second. Print world, and there's our async method. Oh, giving away the secrets. So what's really cool is that is an asynchronous method. It will do this function, then it will go off and wait for this process to complete, and once it does, it will resume and it will do this function. Now we do need to kick it off, so let's say async io.run, and we'll run main. And now we've got this process that will kick off that asynchronous library and allow us to run this. So let's do that. Now I've got this program. We just hard-coded it, or we just live-coded it, which is excellent. But here's sample 1 here in this GitHub repository. And so let's run it. We're in that right directory, Python 1. We can see that it prints hello, then it waits a second, and then it prints world. Excellent. We were running asynchronously. Any questions so far on asyncio or comparing this to threads or popen? Excellent. Let's dive in. I realized that I may not have waited long enough for the camera. So if you do have questions, Annette is right here to catch them in either LoudSwarm or Slack. Or if you want to join us in Zoom and get at questions faster, definitely join us. This will be a lot of fun. So we saw that there were really only two main differences between a regular Python function and this asyncio function. We have async and await. We also need this import here, but that's all we need to be able to create an asyncio function. Is we decorate our method with async, saying to the callers of this function, this is something that you'll need to wait for. And then whenever we do asynchronous work, we want to await it so that we can get at the results. So yep, just the async keyword, the await keyword, and everything else about this code we've already seen before in other Python experiences. So some of the rules of async methods: if you want to await something, it needs to be inside of an asynchronous method. And if you're doing any asynchronous methods, you need to await them. So yeah, it ends up being a little bit, dare I say, viral, where it's like, okay, so I have this method that I need to await, and that means all the code that consumes it needs to await it, which means those need to be async methods. So then I need to await those, and so those need to be asynchronous methods, and then I need to await those, so those need to be asynchronous methods. So you'll notice that async and await just kind of flow through your entire code once you start here. I would argue that is completely fine. That is perfect. That is a really excellent experience there. It is somewhat viral, but it is wonderful to do so. So let's look at some example use cases of using asyncio, and we're going to dig a whole lot into this as we go and create some really elegant experiences. Probably code some of these together too. So we did that hello world. We saw that we ran it, it waited a second, and then it printed world. That was excellent. Here's another thing where we're waiting for a DB call. Now we're importing asyncio. That one's built in, so we don't need to pip install it. But maybe we're also digging into MySQL asynchronously. Now I don't have MySQL installed in this box, so we won't live code this one. But we can see how we've got await here, await async here. This actually kind of builds an internal method. We've got an await here. We can see that all of these things are happening asynchronously, where we're creating a pool, but not holding up the thread while the pool is creating. We're executing a command, but not holding up the thread while the command is executing. We're grabbing results, but not holding up the thread. We're being really good at yielding the thread back to other tasks so that we can accomplish this work as lean as possible and get other requests through the server as well. So the cool thing is the majority of the time that we deal with async IO, we'll probably just do those async and await. And so this first, so many minutes was pretty much all we need in most cases. But let's kind of peel the onion a little bit and take a look at other things within this process too, just to make sure that if we do need to ramp up to advanced scenarios, that we can definitely do that. So let's define a few terms. We've got a coroutine, and basically what that means is an asynchronous function. When we say async def, that is a coroutine. The coroutine object is what that function returns. In most languages, we call this a promise, and JavaScript will call this a promise. But here in Python, we call it a coroutine because reasons. So the result that we get is a future. Now, we talked about it being a coroutine object, and it is that too, but we'll probably call it more a future. That thing that we're holding on to that will eventually yield a result. In JavaScript, we call these promises. In Python, we call these futures. And then we have a task. I could choose to wrap a future or a coroutine object in a task object, and now I can examine that task object to say, is it done yet? What is the result that I got? I could cancel it. I could check the status. And so a task is a really elegant way wrapping that future to be able to examine it and pass it around. The cool part in JavaScript is we get returned a promise, a task straight away. In Python, we do have to wrap it specifically to get where we need to go. That's okay. And then the event loop. Now, the cool part is we probably won't work with the event loop at all directly, but the way that this works is there is that event loop in the background, seeing if these processes are ready to go, if these tasks are ready to go, and if so, then it will execute the next thing. If we don't have the event loop running, then our async methods will never run. Or maybe they will, but they'll run inconsistently. So we do need to kick up the event loop to get asyncio started. And so that's where we did the asyncio.run to be able to start that event loop. We will probably never need to worry about the event loop directly, but it's nice to know that it's there. So these are the 4 things that we'll look at. A coroutine. A coroutine just says async def. A future, the thing that the coroutine returns. Now you notice that I didn't await it here, and so this is a runtime error, but that is a future. It's the thing that we get back from that thing, from an async function. So a task, we'll say asyncio.createTask and give it that function call. And now we have a thing that we can poke at. Now, in this case, I just chose to await that task, but now I have the result. I could also look at the task and say, is the task done? Is the task errored? And then the event loop, asyncio.run kicks up that event loop. And so those are kind of the 4 terms: coroutine, future, task, and event loop. Any thoughts or questions here?
Yeah, one quick question. The await command, is that part of asyncio?
It is part of asyncio. Yeah, that await command gets brought in there.
Great, thank you.
Yeah, so that also means that, for example, if I didn't do this, then that's a typo. You know, the await keyword doesn't exist yet because I didn't pull in the asyncio library.
Got it, thanks.
Yeah, great question. Thanks for that.
Oh, while you're here, so you said the result equals my underscore function would be an error.
Right.
How, I guess you're going to show us what that should look like as a future? Yeah. Okay.
Yeah, the hard part is I'm presuming that I got the actual result and I didn't. I got a future. And so if I try to poke at that future, it's like, well, but I don't have a result yet. But I also didn't wrap it in a task, so I actually can't poke at it yet. And so that's why it's a runtime error. It's it probably won't say, hey, you left out the await. It'll say, you're trying to interact with the future. You need to wrap it in a task first.
I see. So the task is the way to show the function, the future is there.
Right.
And
so
create
to
task
that end, go ahead.
Create task is also in async.
Right. Yeah, so to that end, as I was first learning it, I'm like, so why doesn't it just return a task straight away? Yeah, reasons. I suspect that a future is a lot lighter weight than a task, and maybe that makes it more performant. Great thoughts. Any other thoughts right here? Cool. So when we're looking at adding asyncio to existing code, we may have concerns where it's like, well, but I want to make this async function. How do I deal with it from outside code? Or I might want to call in from an async function to code that isn't async. Can I do that? So the cool part is that the majority of the time, we should just use async and await. We should just presume that the event loop is already running and then just run with it. But we do need to kick up the event loop at the beginning of our program just to make sure it's running. And the easiest way to do that is just to do asyncio.run. Now, the temptation is to say, well, okay, so I have this little pocket of async, so I'll just asyncio.run into that new code from my legacy code, and maybe that'll be okay. Let's take that for a spin. Let's say I've got some sync method. I'll make this one my function, and I'll say def main, and I'll say my function. And instead of asyncio.run, I'll just say main. Cool. So I've got this legacy function, and I'm calling into my new async function. And let's see how this goes. That wasn't it. That one. Nope, not that one. That one. That's what we just live coded. So let's run number 3. Python 3. Coroutine, my function was never awaited, so we got that runtime error. We got main is running. Hey, wait a minute. We never got runs and still run. Yeah, it called the function, but because it did not await the results of the function, it never actually did these things. Or did it? Did it start it but never finish it? Did it abort it in the middle? Do I now have an incomplete transaction in my database? Did my network call start and then abort? It's not deterministic how this turned out. Ultimately, I don't know what happened. Oops. Okay, so let's come back to our program and how might we do this? You know, the natural thing is we say, okay, so let me await this. And it's like, oh, wait, now this is viral. So async this. And it's like, oh, wait, now that means that I need to await this. And we can walk through our code and go, but yeah, okay, so I don't want to do that. That's probably the right move, but I just want to asynchronously launch this. So let's say async io.run, and that will kick off the event loop, which is cool. That means the event loop is only running for the duration of this function, not for the duration of all these things. Let's actually save this as demo.py. And now let's see if we've got this running. So right here, Python 3 demo. Cool, we've got hello world, and then main is running. That's excellent. So we got our method to run, and then we got this thing to run afterwards, and that's cool. Let's take a step back, though, and take a look at this. Maybe this is start background task, and we'll have a def start web server. Hello background task. Web server is started. Start web server. Cool. So that looks about right. We're going to go run my function that'll kick off our background task. Let's actually rename that this way. And now we've got our background task that starts up and does whatever it's going to do. And then we're going to start our web server. So Python demo. We launch our background task, and we don't start our web server until our background task finishes. So if our background task, in this case, only took a second, what if our background task takes 10 seconds? Our web server doesn't start for 10 seconds until our background task is done. Ugh. What do you think? So should we just abandon the whole background task thing? Let's take a step back and take a look at this code. Well, we want to start our background task and we want to start our web server, but we're kicking off the asyncio right here, which means this thing will run and then finish before we start up the next thing. Okay. What if we did this instead? Async, and we'll start it here. Now we're going to get the thing about it was never awaited. And the web server is started, but it never ran our method. So, okay, let's put the await here. Now we're back to that same problem. We did start the event loop sooner, which is excellent, but we didn't get to the point where we could launch both of them at the same time. What do you think? Where should we go next? Well, let's dig into that. We want to be able to run two things at the same time. Here's the part where we want to kick up the event loop as early as possible. Not awaiting a thing is bad, and so these slides are helpful if you're watching this later to reviewing this without the video to be able to understand those pieces that are going on. We want to do asyncio.run as early as possible and as infrequently as possible to avoid multiple event loops kicking up. So the punchline here, calling async from sync code, the best way to do that is to not do that, to let the asyncio viral nature continue throughout the code and just decorate everything with async and await, because now you can get the results back when you're done. You can wait for things and yield threads. And so it's a really elegant way to be able to do this. Just embrace that your code will now have async and await all throughout it. It's okay.
So is the problem is that our start web server was not an await function?
Ooh, good call. So let's do that. Start the web server, await async io.sleep 1, print web server still running. Is that where you wanted to go?
Yeah, I'm from what you said, that's what I'm guessing. It's gonna make it work. I don't.
Yeah,
Fingers
let's try
crossed.
it.
I have no idea.
It looks promising. It's starting the background task. Did that do what we wanted?
No, because the web server should have started immediately.
Right. So let's come back to that one. The punchline I wanted to hit here is that you do want to call asyncio.run, and you want to call that as infrequently and as early as possible. That's the only time you want to call asynchronous code from synchronous code. And the only reason that we have to do this, the best way to do it is call asyncio.run calling main, because we can't say Python async my file. You know, if I could do that, if I could do this from the command line, Python async demo.py, then it's like, oh, okay, now the event loop is already running, and I wouldn't need this async io.run. I could just do await main. Wouldn't that be glorious? Yeah, that's not the way it works. We need one async io.run. But yeah, let's start to try to do two things at the same time. Hello, background task. And I'll make it run for 2 seconds instead of 1, just so that we can get it started. So we saw that in this case, it finishes this one, and then it starts this one, which might be great. Maybe we say return 2, and we say result equals that, and then we need to pass result into here, and this is process and or sleep. And so this, if we needed to be able to pass this variable from this function into this function, then that's a great way. We got to wait for this result as we pass this in. But I'm going to undo that. I'm going to say we want this to be 1. Yeah, we'll return that time, you know, the time that I'm waiting. But I don't want to do both of those at the sequentially. I want to do them both at the same time. So, okay, let's not await them. Maybe that will kick them both up. No, that didn't work either.
What can you explain that error? What is it telling us?
Coroutine was never awaited.
So
what it says is that. Oh, go ahead.
What's the code? What's a coroutine?
The coroutine is this function. It's an async function, and it returned a coroutine object or a future, and yet we didn't await it. We're not like letting it do its thing. Let's come back to right here. There's the coroutine, just an async def. And it's like, hey, you created a coroutine, but you didn't like pay attention to it. You didn't await it.
Ah, got it.
Yeah. Okay, so we do want to await it, but let's go grab the future. So let's say background task. And let's say web server. Now these are futures. I haven't awaited them yet. But what if I now await them? I launch them both, and then I await them both. Let's try that. Cool. So now the two of them are running in parallel. And so I actually would have expected it to say background task and then web server is started. I'm actually surprised that it didn't. But now those two should be running in parallel. I grabbed the future, and then I launched those two, and then I awaited the future to be able to get those two things to run at the same time. So the cool thing is we're just using async and await, and we are eventually awaiting them, but we're launching them both at the same time. Cool. So that's interesting. There's another syntax that we can use here in the async IO library. We can say async io.gather. And to the gather function, we can pass in an array of futures. Well, I happen to have two futures, background task and web server. And so that will get them both running, and we can see, oh, and then we need to await that, and then we can get our array of results. So background result and web server result. And this is where this analogy is kind of breaking down. Maybe this is just task 1 and this is task 2. Or in this case, because this is waiting 1 second, it's task 1 and task 2. So let's start task 1 and task 2. And so let's start task 1 future and task 2 future. And then we get task 1 result and task 2 result. And then let's print those. Print task 1 result and thank you, GitHub Copilot, task 2 result. There we go. Now we're going to launch them both, and then we'll wait for them both. And so let's run this one. And, ooh, I have a typo, line 24. I don't see where my typo is. We're at line 44. Unhashable type list. Task 1 was never awaited. Yeah, it was. Okay, so let me simplify this a smidge more. I was going to take a step in between, but instead of doing that, let me just say task 1 and task 2, and I'll pass in that array. That's a little bit simpler to do an asyncio.gather. I'll just pass in those two coroutines. Is it going to be happy now? Nope. Oh, I think it's going to want me to do this. asyncio.create task. The other asyncio methods want a task, not a future. So let's see if this one will get us through.
Since we loaded the asyncio library, couldn't we just use create task?
Yeah,
or am I missing
like that?
something? Yeah.
Yeah, that should get us through. And then we pass those in together, and then we await the result. I think I might have an overactive compiler here. It was never awaited. If arg not in arg list. Okay, so I'm going to call this a demo fail and reach into my stash. Here's these two methods. In this case, I have a do work function that takes in a number of seconds. And so I'll just sleep there. So I want to create my do work function waiting for 2 seconds, and I'll create my do work function waiting for 1 second. Now I have those two tasks, and then I can await them both. So then let's print the results, number 5. Yeah, so it launches all the things, and then it waits for all the things, and then they're done. So now I'm curious. I'm going to spend an hour after our call trying to figure out why mine didn't and this did. So that's kind of cool. But then here's an example of asyncio.gather where we just pass in. Oh, I see my typo. I passed in an array, not individual results. So let me see if I can go fix this by removing the array. And of course, now it's going to work great. Yep, there we go. The web server started, the background task has started, they're still running, and then we get the results from both pieces. There we go. That looks better. So asyncio.gather is helpful because you can now await two things. Let's actually see if we can remove the create task thing, because I wasn't going to demo that one yet, but yeah, there we go. We can launch a bunch of coroutines. They'll all run in parallel, and then we can harvest their results and take action on those results.
Will you go back to that demo page so I can see what you did?
Yeah.
Okay, thanks.
Yeah. And now that we don't have the create task, then it probably is a little bit easier to read like that. We're just passing in each of the coroutines that we want to run, and then we gather the results and await that, and it will return an array of those task results. I find it to be a little bit easier just to say task 1 future equals task 1, and not semicolon, task 2 future equals task 2, await task 1, future, await task 2 future. Actually, task 1 result equals. I personally find this to be a little bit more legible than this. I grant that this is, 1 line and this is 4, but now I don't need to worry about any of the other details of the asyncio library. I'm using the async and await keywords. Ooh, Catherine. I see you have a concern. What's your thoughts?
Microphone.
I think you might be muted, Catherine.
So for your list, you could have put a star in front of it. I think that might have helped.
Ah, good call. Let's do it. Like that? Okay, Catherine is awesome. And the balance of this class will be taught by Catherine because she's amazing. Thank you.
Please explain what the star is doing.
It dereferences a pointer, if I remember right. Is that right, Catherine?
My thing about it is like unpacks the list, maybe? I don't know. I'm
yeah.
not sure though.
Yeah, that's a great way to think of it. In JavaScript, we would do the spread operator like this. And in Python, we do it like this. Brilliant. So I'm going to stash that one just because that was a brilliant example. And then I'm also going to do it this way, which ramps us up nicely into my next demo. So we've got these two things happening at once now, which is really cool. What if we want to only get the first one that succeeds? Let's say we ask our cache server for the result, and we also ask our database for the result, or we ask a really long-running API, and we wait so long for our server, and we just want the first one that succeeds. The cool thing is that we can pass in I just train wrecked myself. Okay, so we have this. We can say, actually, let's do poking at task results. So we awaited these things, which was cool, but we could also say, instead of asyncio, we could say task 1 result equals async io.wait task 1. And that is a similar syntax as this. So they do the exact same thing. Async io.wait just avoids the await keyword, but async io.wait gives us other options too, which is really cool. So we can say async io.wait, but I only want to wait timeout equals 1.0 seconds. So in this case, task 1 is going to take 2 seconds. So I'm not going to wait long enough, and I will throw an exception. So let's try this. Let's try. We'll wait for the result. And if we got the result, we'll say print task 1 finished. And let's also get the result for task 1. And then let's say except we got a timeout error. Print gave up. Waiting for task 1. Wow, there's a whole lot of typos in there. Okay. And now we'll print all done. Cool. So we want to wait, but we only want to wait a certain amount of time. We can't pass this parameter into async or into the await, but we can pass it into asyncio.wait. So our task should take 2. Let's actually pass in sleep, and we'll sleep that amount of time. And we'll return that amount of time. There, now we've got a little bit more generic method. And to that end, we can say that's exactly the same here. Cool. So we'll launch that thing. We'll wait for 2 seconds, but we will time out in 1 second. And so we'll either get our result or we'll get our exit code. So Python demo. Oh, let me double check that I saved. I did. Very nice. Demo. Oh, what did I not await? Line 28 and line 30. Oh, yes, that no longer exists. You are correct. I hate it when my compiler is right. Wait was never awaited. You're right. There we go. So it's not replacing await, but it's rather giving us more options with await. That's a better way to say that. Oh, I still failed. Expected a list of futures, not. Oh, they recently changed await. I think what it's saying is I have to async io.create task, or I'm about to reach into my stash and figure out what my typo was. Yep, I'll reach into my stash. So wait only for so long. So we say, oh, wait for. Wait for. Thank you. A typo the things. Okay, so async io.wait for this task, but only this long. There we go. Sleeping for sleep seconds. I forgot to put the F there. And I may need to change the quotes, and now it'll format correctly. Cool. Sleeping for 2 seconds, gave up waiting for task 1, and we finished. Cool. So now we called into the web server. There are a long-lived API, but we say we're not going to freeze the freeze the user's experience forever, we're just going to give up after so long. So then the magic question, did it finish? Let's imagine that we're saving a database result. You just created a new record, or we charged a credit card, or any kind of that activity where we're taking action. Did it finish? We don't know. And the hard part there is because we don't know, it's hard for us to really take any action. So probably we don't want to time out. Maybe we want to create some other mechanism to be able to only wait so long. Or here we can say error dot. Oh, I have to create a task first. So how might we cancel this? So I'm going to say, let's create a task. Task 1, and I'll pass in 2 seconds. Because I've now created a task, I have a thing that I can connect to. So I'm going to say asyncio.wait for that. I'll even say task1 future, just because now we're using the right terminology. We've got this future. I'm going to wait that long, and now I say, okay, I've got the result. But if I gave up, I'm going to say here, task1 future. Oh, this isn't a future. This is a task. I created a task out of it. Sorry. Task1 dot cancel. I want to cancel that task. We just gave up on it, but it might have continued. It might still be running. It might still be consuming CPU, but now we're going to explicitly cancel it. So canceling task 1. Our experience is exactly the same, but we're now using the thread pool more effectively. We're actually saying, no, I really want this thing to be done. Abort it. But then back to our original question. So did we charge the credit card? Did we not? It's hard here because the results are not deterministic. If we've made an API call and that API call continues after we've disconnected with it, then maybe it did save. Timeout is interesting, but timeout is really great for reading results. It's not great for saving results. If we're going to change data, we probably want to avoid timeouts. If we're going to read, read from the database and read from the cache, then we might choose to time out and not and then cancel the task when we're done. Any questions there? I don't think I did a great job explaining that.
I'm sorry, I'm slow in the uptake. So explain to me the what we're doing with the try. So the first thing we're doing is we're creating the async task, which is going and running that code. The test 1 result is the future, right? No. The task 1 task is the future.
Yeah. Well, technically, there's
we're
the
including
future.
Right. Okay. So we've
And then we're
included the
taking
future
the future and we're calling create task out of it. Now that we have a task instead of a future, we can still wait for the task. We could also wait for the future if we wanted to. But now that we have a
it's
task,
like a task, like a is a task like a function that is ready to happen when we call it to tell it to do something.
It's
Not
still
really.
a promise of a future result, but it has additional methods on it that a future does not. So it has cancel, is it done? What is the result? A future just has what is the result, but this has all of these other methods too. Oh, there's a lot of internal gets in there too. And the one that we
It
just
allows us
used
to
was
to
cancel.
time out. Okay, on the cancel, right?
Right. If we were looking at task 1 future, there's no cancel. It's just kind of like, okay, that's a lightweight object. We wrap it in a more feature-rich object that allows us to be able to do things like cancel it.
Got it.
So the majority of the time, we won't need to create task. But in this case, it was helpful because then we could cancel it when we were done. And I'm actually curious now, is this going to work or is that going to blow up? Yeah, it went, hey, you just created a task, but you didn't await the task, you waited the future. Yeah, so I was wrong. This one just does need to be the task. That's better. Now, in this case, we're waiting for we launched it for 2 seconds and we waited for 1 second. So let's wait for 3 seconds. And now it finished in time and we got the results. And I forgot the F again. From Willie, is task 1 kicked off by creating the future? The future is created by running the function, the coroutine. This coroutine is a coroutine because it has the async keyword before it. And so here's that coroutine. And the result of a coroutine is a future. And we're going to wrap that future in a task so that we have additional methods. If we didn't want to cancel it, so let's remove this cancel, then we wouldn't need a task at all. And we could just wait for the future instead. So it's a little bit weird with the terminology, but to that end, if I didn't want to cancel it, this method could be that. And yeah, that's a lot simpler. We got in the weeds here with I wanted to be able to cancel it, and what's the difference between a future and a task? And so yeah, in the majority of the cases, Willie, I completely agree. This is the way I would go instead. So let's do this. We'll see that the results here are pretty much identical. We're going to sleep for 2 seconds. Then now we're done sleeping and there's a result. Then we'll launch it again. And I made a typo. Where's my typo? Oh, I didn't undo this when I put it back. Cool. So now that will work as expected. I'm also curious why it didn't notice I used that variable. That's kind of fun. There we go. Oh, because I didn't use the variable. Yeah. My compiler was helping me and I was not paying attention. Cool. So now we waited a certain amount of time, and if that time elapsed and our task wasn't done, we were able to cancel that task. This is great for retrieve operations, for get operations. But if we're changing data, we probably don't want to cancel it because the results are indeterminate. Did it work? Did it not work? We just kind of gave up listening, and so we don't know if it succeeded or failed, or if it aborted. We stopped. We're in a CPU-bound process that is very self-contained, then canceling can be great for retrieving the resources. If we're making API calls, we probably just want to let them finish. So we did two things at once. We did wait only so long. We canceled the task when it went too long, which was really elegant. What if we only want to wait for the first result? So I'm going to do this, task to future equals task 2, and I'm going to wait for 1 second. Actually, I'll just make this task 1 for 1 second and task 2 for 2 seconds, but I'm going to put that one first. And actually, I'll even just create the task straight away. So asyncio.create task. And I may actually even, that one's now the task. We may simplify this a little bit further, just because, the whole, that just kind of makes that one-liner that's a little bit simpler. So I'm going to use asyncio.wait instead of wait for, and I'm going to put in task 1 and task 2 into this array, and I'm going to say, return when first completed. Now, the cool part about first completed is I'm going to say, I'm going to hit my database and I'm going to hit my cache server. And whenever either of them return, I want to get that result. I don't want to have to wait for both. And to that end, let's set these in place right there, because now I don't need all of this other mayhem. And it's going to return an array that is completed and actually, I'll say this, finished and unfinished. So this is an array of the finished tasks, and this is an array of the unfinished tasks. So we don't have that timeout error anymore. But now we can say print finished. And because this is an array, let's pop the first thing off. I'm going to presume that there's only one that finished. And then let's go look at the result of that task, finished task, and it will give us the which one finished first, the one that waited for 2 seconds or the one that waited for 1 second. So we launched them both. The one for 1 second finished first, so we finished the task, and then we just ended. Now, what about the one that's waiting for 2 seconds? Did it finish? Is it still running? Did it do its thing? We learned previously how we can cancel things. So let's take a look at this, and we'll say for task in unfinished, let's task.cancel. And now we've kind of cleaned up our mess. We've said, hey, I know those, I didn't need those extra things. Let's not keep them running. They were only getting data anyway. So now we've got our content. And the cool part is that I want to do this. I want to just pass in an array of futures, not an array of tasks. And they recently changed asyncio.wait to not allow an array of futures, but only allow an array of tasks. So I'm like, this feels a little bulky to me. Fine. But that's awesome. Now I'm only waiting for the first one that's done. I'm not waiting for all of them to finish. By comparison, if I wanted to wait for all of them to finish, then we would do something like this, where we would say task 2 future equals task 2, task 1 future equals task 1. Pardon me. And then we could say await task 2 future, await task 1 future. Let's go grab those results. Task 1 result. Now they're both running at the same time. We're getting both the results. And so if I wanted both of them, yes, this code is much simpler. If I only want the first one, then I can do this instead. In most cases, just using async and await is a much simpler solve than doing all of the other mayhem. But let's go wait for the first one to finish. So we launch them both. We grab the first one that finishes, and we cancel the rest. Any questions here?
And you said the first completed is built into async IO and is looking for the first task of the wait
Yes.
line 27.
In this case, I launched the 2-second one and the 1-second one, and the 1-second one finished first, so it ended up in this array. The 2-second one was not done yet, so it was in this array.
Got it.
But if I did this, then now the finished array has 2 elements in it, so I made the incorrect assumption right here. Cool. Well, this was a lot of fun to look at a lot of cool edge cases. We looked at how we can cancel the task if we gave up waiting that long. And the cool part about these code samples is I would invite you to pull them up and poke at them, change the timeout period and the do work period and see how those interact in interesting ways. We also talked about how it's helpful to cancel them if we have a synchronous process retrieving data, asynchronous process retrieving data, and we just don't want to have that keep running. But we talked about how saving it might do bad things. We looked at how we might wait for only the first one, that create task process and the first completed, canceling the ones that didn't finish. We talked about how it's an array, so I made the assumption that there's only one here. But then we also looked before that at how we could launch 2 things at once, where we can just launch the 2 and then await the 2. We don't necessarily need to do the await right after the thing. And we looked at, instead of await, we could use asyncio.gather, passing in each of those elements. And now we only need to await once. We get an array of results. And it will kind of do that. Which one finished when, it can keep track of that. But the majority of the time, that was our other method. The majority of the time, just using async and await just async and await is the easiest way to solve this. The majority of use cases will just use async and await. And the more that you can start to think in just async and await, the more that it just naturally flows. Part of the cool part is if you've used async and await in JavaScript, it works exactly the same here in Python. And so I've seen some people, myself included, that are like, okay, so I'm approaching asynchrony in Python, and I'll just think in JavaScript, but type Python code. And it's like, yeah, that's exactly how it works. Once we step out into the other things, then it's where it gets weird, where we have to start leveraging the asyncio library more to be able to get at this. We talked about how we might do two things at once. The cool part is the slides nicely enumerate this. If you're only looking at the slides, here's the results. We actually did it live instead, and that was a whole lot more fun. There's asyncio dot are the two awaits, and asyncio dot gather, which is cool. The timeout, canceling the task. And I don't have slides for doing only grabbing the first result, but it's really important that if we're changing data, that we don't cancel it, that we let it continue, because it's not deterministic if we cancel it. So only cancel if you're doing pure functions, if you're reading data. So the really cool part, we got to end early, which is amazing. Asyncio is a great way to be able to think synchronously, but code asynchronously. In all of these examples, as we were looking through them, it was really easy to understand what the code was doing. We just looked down our function and we could see it. Asyncio is about thinking synchronously and running asynchronously. I think it's brilliant. The code is online right now. The slides as well at robrich.org. And you can find me on Twitter at rob_rich or on Mastodon at robrich@hashiderm.io. And if you're watching this on demand, definitely find me there and let's continue the conversation. For those here in the room, what are your thoughts? Where should we go further? What are some advanced things where you've hit asynchrony that we should explore further?
So at the beginning of your talk, you said that everything in async IO still happens on one thread, right?
Right.
What are our options for going into multi-thread?
If we want to do multi-threaded, then we have to come back here to threads. And launching threads is a pain, but that's what we do, is we'll launch a thread, and then each of those threads does its thing, and we're not using async and await anymore. Yeah, it's awkward.
We can use async within each thread, but not to control each thread.
Right. But the cool part about the event loop is it does kind of manage multiple threads. So if we're using async and await within threads, but the threads are kind of mutating between each of the tasks, like the task may resume on a different thread than it started, then that's totally fine. And so the cool part about mixing async and threads is that they play really well together. It's like, oh, and my application is more performant. That's great. Yeah, I wish we could get away from threads. What are some scenarios where you've hit asynchrony that we can explore together, where you really wish that you could use async and await or async IO that we might be able to solve?
I had something that this would have been really helpful. Well, maybe, yeah. Actually, it wouldn't have been. Never mind.
Yeah, it's like, I got a new hammer. Where are the nails? Well, excellent. This was a lot of
Actually-
fun getting to share with you asyncio. If you find a question in an hour, I'll be here at the event. Or, if you find a question tomorrow, hit me up on email or Twitter. Right here on my website, you can grab all the social links right here, including this link that will send me an email.